A very warm welcome to fellow data enthusiasts to our highly anticipated webinar on the introduction to reinforcement learning, exploring fundamentals and applications. Today we have the honor of hosting Ratnakar Pandey as our esteemed speaker. So Ratnakar is an experienced advisor and consultant for generative AI implementation, and he comes with a strong background in data science and AI consultancy. With a total of over 19 years of experience working at companies such as Amazon, Cabbage, Citigroup, Target, Texas Instruments in the data science domain, Ratnakar today will be sharing his insights and knowledge on reinforcement learning. So a few aspects that will be touched upon during the webinar would be, exploring the basics and, the concepts that go in reinforcement learning from human feedback along with its significance. Real world examples showcasing the successful implementation of reinforcement learning techniques and a demo of a simple Python based reinforcement learning technique. So this webinar is not just a passive learning experience. It is an opportunity for active engagement and collaboration. So feel free to ask questions, share your thoughts, and actively participate in discussions that will arise. And regarding the questions, Ratnakar will address them towards the end of the webinar. So without further ado, let us embark on this incredible journey of reinforcement learning. Once again, I would like to extend a warm welcome to each one of you. And thank you for joining us today. Let's make this webinar an unforgettable learning experience. So now I'll be handing over the virtual stage to Ratnakar. So over to you, Ratnakar.
Thank you so much for such a great introduction, Shraddha, and really appreciate once again for giving me the opportunity to come on the platform and talk to the participants. And folks who have joined either early Sunday morning or Saturday evening, their time, or I mean, anytime in the weekend, I really appreciate you taking time out to come and, attend this webinar and look forward to having a good discussion, and hopefully you'll be able to get good value out of your time as well, right? So as Shraddha mentioned, let's keep it interactive, right? So it's not going to be a one-way street. I have many slides, but I would be preferring answering your questions, towards the end. So I will keep aside maybe 10 to 15 minutes, just in case you want to ask anything and we want to have a discussion around those topics. So we'll keep that time aside. We'll pace accordingly so that we can cover most of the things in that timely fashion, right? So just very quickly, folks, what I'm going to do is I'll share my LinkedIn profile. So if you want to connect with me, feel free to do so. And I will do the same from my side. So I'm just gonna put that over there. And some of the things that we will discuss today are there in my blog. So you can also take a look at that. And it's all free. I mean, there's nothing that is paid and stuff like that. So, but you may find certain information which might be useful for you, right? So happy to connect with you and happy to chat with you in future as well. It's not going to be one-off interaction that we're going to do, but looking forward to a more continued relationship, right? So let's begin in terms of what we're looking at today. We will talk about the reinforcement learning, right? And I will give you tons of examples, and I will also walk you through in terms of all the key terms via example of the automated vehicle or the autonomous vehicle or the self-driving car, how exactly that really works in terms of the reinforced learning. So that is going to be the focus area for us, right? I'm just going to move few things here and there so that I have space on my desk. Okay, there you go. So what is reinforcement learning, right? It is form of a machine learning, and I will give you some time on the screen so that you can take a look at as well. And I will try to minimize my window here so that I can see the screen as well. Okay, great. So I'll give you maybe a few seconds to take a look at that. And in the meantime, I'm just going to highlight some of the keywords that you should be paying attention to. And don't worry, I will explain all of that. Okay, so this picture in the bottom of the screen sort of gives you the hint of what the reinforcement learning is. There is an agent, and that agent is taking certain actions in certain environments to maximize the reward. It is a special type of machine learning, and very, very quickly, this is also very, very similar to the trial and error, and having some sort of mechanism in terms of giving reward for the right decision and giving punishment, or like taking away the points for the wrong decision, right? And the closest analogy you can think about is how you would train your pet, right? I mean, let's say a dog you have. Uh, how would you train your dog to go fetch the newspaper from your main gate on a regular basis, right? So you basically give them a treat if they do it correctly, or you'll just say bad doggy, whatever, right? I mean, in terms of not making the right decision. So that's how basically reinforcement learning algorithms really work. So we have the agent who is supposed to be learning that behavior. We have an environment where they are operating in, and we'll talk about that via the example later on. And then we have some actions that they'll be taking, and those actions will be rewarded or punished, and that will over a period of time via the trial and error, in a controlled fashion, will reward it to will generate an optimal policy, which will basically tell them how to do those actions in the future. So that's the crux of the reinforcement learning, right? Very quickly, what are some of the examples of reinforcement learning? Okay, so there's a chat. We'll handle some of those questions later on. Can you elaborate reward and punishment? Sure, Anamika, we'll do that later on. So I'll look into your questions later. So whatever questions you have, you can keep on putting them in the chat, and I will come towards the end and try to address that. And hopefully some of those questions will automatically be answered by the time we finish some of the other slides, right? Is that okay? All right, great. So robotics, one of the biggest example of reinforcement learning is in the robotics, right? And what are they trying to do? I mean, they are trying to grab certain object. They are trying to move around. They are trying to, help in terms of the manufacturing. They are trying to do many, many different things, right? And the environment will keep on changing around them. So if you are looking at the, let's say, car manufacturing, right? The environment is not fixed. Sometimes they're making an SUV, sometimes they're making a hatchback, sometimes they're doing certain other things and all of that. So things look a little bit different, and they have been, programmed in a certain way that they will learn that behavior and all of that. But of course, I mean, we are not doing the live testing on the shop floor. All of that has been done in the pre-training stages and all of that. But robotics is a big consumer of reinforcement learning, right? I completely forgot. I think, I mean, everybody can relate to that. Chat GPT. I'm pretty sure everybody has used that, right? So Chat GPT has been trained on the process of reinforcement learning through human feedback, RLHF framework, right? What does it mean? So it will, like, all the bots that they have designed, like the Chat GPT itself is a Q&A bot. So it will learn that behavior in terms of, what is the right answer to be given based on the human feedback, right? So there's a signal that is being sent for the reward. And do you think that testing is happening as of now? Like the human feedback is happening as of now? And if so, how? I will look at your chat. Okay, so how do you think that is happening? Vatsal, if I read your name correctly, or anyone else? How do you think they are still reading that? So when you log into the chat GPT and you get, let's say you ask the question, what is the temperature in Bangalore, right? I mean, it's not going to be current, actually, it's till 2021. So for example, you can ask, what is the capital of Karnataka? And it comes back and says the capital of Karnataka is Bangalore. And then you will have either a thumb up or thumb down, right? And that's the human feedback that you're giving. That's the reward or the punishment you're giving. Thumb down meaning that no, that is not the right answer, or I'm not happy with that answer. Thumb up meaning that I'm happy with that answer, and that gets fed into the processing again. So ChatGPT, Bard, or any other sort of bots, they're still learning from our interaction, whether we like that output that they've given or not. And that could be both in the explicit way, meaning I'm giving, certain rating, thumb up and thumb down, or implicit also. So, for example, if I copy paste, or if I say, great, can you now elaborate this by doing X, Y, Z, or can you add these things and so on and so forth. So it's all getting fed in terms of training the bot, right? So it's happening in a lot of different places. In gaming, again, a big user of reinforcement learning, because the game levels, game complexity, the design of the games, everything keeps on changing, right? And they have been, well accomplished uh, bots, or basically the agents who have aced their game using reinforcement learning, whether it's a chess or any other sort of game that we're looking at. And that's another big use case for the reinforcement learning, right? Autonomous vehicle, self-driving car. There are tons of examples. I mean, Google, for example, right? Tesla, all of those people are using, you know, a large portion of the training is via the reinforcement learning. And don't worry about the details over here. This is exactly the example I'm going to walk you through for all the key terms that we are going to look into the reinforcement learning. Finance. This is very interesting, because a lot of people wouldn't think about that finance would be using reinforcement learning, right? Particularly when there's so many things at the stake. But believe it or not, I mean, there are a lot of those bots which will be doing the trading based on the live conditions in the market, right? So there are bots which will be doing the trading in the equities, in the options, in the derivatives, right? In debt, whatever, I mean, are the different instruments in financial world. There are bots which are doing that trading, and they are making the buy or sell decision, right? And not the humans. And there might be, some human intervention and stuff like that, but to a large extent, the bots are making that decision in terms of when to buy, what to buy, when to sell, what to sell, and so on and so forth. Whether to go long on the stock, whether to go short on the stock. All those strategies are being done by the algorithmic trading, which are being reinforced by reinforcement learning. Just trying to give you some motivation that this is not such an abstract concept, but this is being used in multiple places as we speak. Healthcare is another big user of the reinforcement learning. What should be the right treatments? What should be the policy in terms of what medicines to give in what strength for how many days, given the patient data, medical guidelines. And of course, this is not happening on the, like, the live patients. I mean, that wouldn't be happening. But I think, they will learn from the past behavior and stuff like that in terms of, how we do it. Or they may have sort of a pilot that they're running on, certain testings and stuff like that, because this is concerning with the human health. Recommendation systems, again, big users of the reinforcement learning, where, I mean, they will know whether the product that I've recommended. So let's say you're on Netflix, right? And Netflix is known for, making good recommendations. Of course, you see the top 10 movies and stuff like that, but they also make personalized recommendation in terms of, what is it that we should be watching. And again, based on, whether you watched their recommendation or not, or if you open that link but you watched only for 5 minutes and then you dropped off, or you started watching something else, they are knowing, whether I'm making the right recommendation or not. And those recommendation engines are learning from the reinforcement learning, because it's a immediate process of learning and then optimizing the algorithms and so on and so forth. So that happens. I mean, same happens with any of the e-commerce website as well, in terms of the product recommendations, and any of the services recommendation as well. So that's, a quick motivation in terms of the reinforcement learning. The idea is that, and these are just some illustrative sectors. So, for example, you may say, hey, how come manufacturing is not here? Or what about the technology, right? Or what about the search, right? And so on and so forth. Pretty much, all the areas are using reinforcement learning up to a certain extent in some shape and form. But these are, good examples for us to keep in mind when we're looking at that. Okay, so we will carry on. I think these are the terms everybody is aware of. So I want to compare the reinforcement learning to supervised and unsupervised learning, so that you can get sort of like a feeler of, how it is similar or different from some of the things that you are aware of, right? By the way, I mean, people are aware of the term supervised and unsupervised. Just a quick check. I will open up your chat. Okay, great. So you do know supervised and unsupervised learning. Okay, awesome. Great. Yeah. So these are, the algorithms that most of us are familiar with. Supervised learning. unsupervised learning, right? And this might be something new, or we may have heard about, but we don't know how exactly that compares and contrasts to what we're looking at over here, right? So in supervised learning, what you have is basically what we call as the labeled data, right? An example of that is, let's say you're building the default model for the financial industry, right? So default model is nothing but who is going to default on your loan. So you know that if I have, let's say 10,000 customers data, 500 of those customers have defaulted, and 9,500 customers are good. So between the good and the bad customers, I can build a classification model to say if I have a brand new customer coming in, what is the propensity that this customer is going to default on their loan? That's a typical way of doing a supervised learning algorithm. Similarly, you may have sales data on a particular retail provider, and then you're trying to do prediction of their sales as a factor of their marketing budget, the pricing, the season, the discounting that they're offering, promotions they are running, advertisements they are running, whatever. I mean, like we have seen all of those things happening. So that could be a prediction model. Again, you have a labeled data, which is the sales, the actual sales which has happened in the past, and using that, I'm able to make the prediction. So that's the supervised learning. Unsupervised learning, on the other hand, does not have the label data. So your label data is not available over here. And what is the purpose of the unsupervised learning is you're just trying to do some sort of pattern analysis, like a clustering exercise, principal component, right? Your I'm just trying to think about, like any sort of feature engineering that you're doing, any sort of pattern you're trying to recognize, any type of grouping that you're trying to form, all of those are your unsupervised learning, right? And reinforcement learning is basically, it doesn't have a lot of historical data. So the problem is that you don't have all of these data, and you want to learn as you are doing the experiments. You want to learn as you're interacting with the environments, and you're actually learning on the fly, right? And based on that, you're actually able to generate that behavior. So there is a huge difference. So supervised learning, you need tons of data. Unsupervised learning, supervised learning, you need tons of data and the labeled data. Unsupervised learning, definitely you need data, and labeled data is not necessary or not required. And reinforcement learning is you can small with a smaller subset of the data or the experiment that you want to run, and learn as you're going on, right? So what is the goal? Predict or classify new instances. So going back to this example, if I have built a model for doing the default prediction, I want to see how this model is making the use of the historical data in predicting something new. And then we'll know whether that model is accurate or not in terms of the live results, what happened, whether that customer really defaulted or not, and then based on that we'll train. Here we will just try to find the patterns, the groupings, the similarity, and all of that. The objective of the reinforcement learning is to maximize the rewards and learn what actions we should be taking, right? So the objective over here is to maximize the rewards, because it's more based on the reward and the punishment mechanism, and how we can optimize those rewards. And I will do a Python demo for you, so you'll get a more gist of what really happens here, right? Here, the feedback is very clear, because you have what we call as a ground truth. Your labeled data is nothing but your ground truth. So you know exactly what has happened, and using that, you're trying to train the relationship of y as a function of your feature space. You label as a function of your feature space, right? Here, there is no feedback, and it's a subjective decision as well, right? You may form a cluster which makes sense to you. I may form a clustering algorithm using k-means, which makes sense to me. There's no right and wrong answer per se, right? Or you may do certain way of dimension reduction that may or may not be agreeing with what I'm doing, right? So here, the feedback is not necessarily immediate, and we don't know ahead of time, and there is a delayed feedback as well. So action is taken, and then the feedback is given. So that's how the system or the agent really learns over a process of time. And tons of applications, right? So most of the applications of the reinforcement learning will be in the area of gaming, robotics, recommendation system, self-driving, all of those things, right? Okay, let's quickly take a look at some of these terms, and don't worry about them. But I will give you maybe 30 seconds to take a look at that, and then I will walk you through each of these terms and much more. via the self-driving car example. So some of the questions that you may have, okay, great, I understand what is it that we're trying to do, but how do I know what is what over here? So that will become clear once we go through that example. So I'll give you maybe 30 seconds to take a look at this, and then I will go line by line, and then I'll explain you each of these terms in more detail. Okay, so we'll just begin very quickly. Hopefully, you got some gist of it. So, agent is the one who is taking all the actions and interacting with the environment, right? So, agent in this case, for example, when I said you are training your pet dog to do certain things, agent is nothing but your dog, right? In the self-driving case, agent is nobody else but the car itself. So, who's doing those actions? Who's learning that behavior? That is the agent entity. Environment is the whole system where the agent is operating in, and I will walk you through in the car example later on. State is what is the current situation in the environment, and how does agent perceives that environment around it is basically the current state, because state will keep on changing over a period of time. Actions are the actions taken by the agent given the state of the environment that the agent perceives. Once the action has been taken, there is a reward mechanism or punishment mechanism in place, which will give a certain signal back to the agent, and that signal will be perceived by the agent and will be, used in figuring out what should be the policy, given that where we are as of now and what we want to accomplish. Right? Policy, I just mentioned that term, is the strategy used by the agent to select the best action given where they are, right? What should I do now? So, I mean, let's say I'm building this car algorithm, which I will talk about a little bit later on. So I can go north, south, east, west, for example, or left, right, and so on and so forth. So what should I do now? That's the policy. And why should I do that? Because that has the maximization of the reward for that, right? And that's where we will be actually looking at in terms of how the RL algorithms really learn that behavior. Value function, the expected reward for an agent in a particular state. So any state, let's say, I mean, there are 10 different actions I can take. Let's say I'm a robot, and in a particular state that I'm in, I can take any of these 10 actions. So what is the value V1, V2, V3, V4, V5 till V10, which is there for all these possible actions? And let's say V3 has the maximum value. V3 says you will get plus 20, and everything else is lower or negative. Then that policy says you should choose V3, is what basically the policy says, right? So take the route which is going to give you maximum reward, right? So that's how basically we'll be looking at. Multi-arm bandit problem, term that we basically, it's again coming in from that, the bandit game that we have in, a lot of these gaming centers. So you don't know which lever to pull down to maximize the reward. So that's where the agent is trying to learn from multiple actions, as I spoke about over here, with unknown probabilities ahead of time, and then it's trying to see how it can maximize the reward. Q value, the expected reward that can receive from a particular action from this, right? Explore exploit dilemma is, something when you want to do as a exploratory thing, and which is going to have a potentially higher value for you, and exploit meaning something that you know very well but may not be as a high value. So for example, I can just talk about all of us, right? So explore exploit dilemma for all of us is, let's say we have a well-paying job, right? Now we have to decide whether we should go for further studies, MBA, masters, PhD, whatever, right? So the explore over here will be taking that path with unknown future. I mean, there's no certainty. I mean, that you, after your MBA, after your masters, after your PhD, you will get what you're thinking about. There's no certainty. So that's the explore path. Exploit meaning that I know that I can earn 5% more next year, 10% more next year if I do what I'm doing as of now. That's the exploit. So if you continue to exploit the current situation, you have, something which is much more certain, but then you're not maximizing the rewards, potentially not maximizing the rewards. So agent tries a combination of this in terms of a, epsilon grading policy that I will talk about next, to say, okay, fine. I mean, I know that this really works and I should continue to exploit that. But if I continue to do this, my rewards will be lower than what I could have gotten if I were also exploring a little bit, right? So that's the explore exploit dilemma. And there is a mechanism that we have in RL to handle that as well, right? The epsilon grading policy with the letter epsilon is trying to strike a balance in terms of taking that risk. So the probability that we are saying, okay, you can take this epsilon probability, and if you were to do a certain action, you have, let's say that epsilon I'm deciding as 10%. So in 10% of the situations, you can take a random action, or in 10% of situation, you can take an exploratory action just to see what really comes out. That's what basically this epsilon grading policy is all about, right? So just keeping pace with the time, people, I'm gonna move on, and when I walk you through the car example, each of these terms will become very, very clear to you, hopefully. So the self-driving car, I mean, of course, we don't have those many cars in India as of now, but I mean, in some of the developed countries, I mean, they are quite common, right? In fact, there is a video also, or meme sort of thing, where I mean, a senior citizen is like, completely surprised looking at a self-driving car, sitting in the car, and the car is doing a phenomenal job and stuff like that, right? Okay, so in now we will look into the terms. So the way that we have structured is what is the key term in the reinforcement learning, and the example via the self-driving car or the autonomous vehicle. I mean, when I say self-driving car, it could be any vehicle, right? But they work on the similar principles, right? So how do the cars know? They have all these sensors and the processors and stuff like that, pretty much in every area that you can imagine, right? They have computer vision, they can hear things, they know what that things really mean. So there's a lot of training which is already gone in the background. But then there is also RL sitting on top of that, which is taking some of these actions based on these sensors and the digital data point that they're processing, right? Agent refers to the entity. I'll choose a different color. Agent refers to the entity that interacts with the environment and learns to make the decision or take actions to maximize the cumulative reward. In the case of the self-driving car itself is the agent. And what is it processing in the terms of the environment? What is the traffic condition? Are there pedestrians on the road? What is the road conditions that we're looking at? Shall I be accelerating or braking? Shall I be turning? Which direction I should be turning, right? And based on these actions, the car will get the reward or the penalty. So that's the agent, right? Same thing as what we have spoken about in the case of the pet dog, that the dog itself is the agent and it's trying to learn that behavior. Similarly, over here, the car is the agent in operating in this external environment where you have all these things and the car is processing that and making a decision in real time. What is an environment? External context or the system in which the agent operates, right? So environment could be really big, could be really small, could be, any level of complexity that you can imagine in the environment. So if I'm a bot which is just meant to clean the room, my environment is, the room dimensions and all of those things. And that's what my environment is. I'm processing that. If I'm a car, then my environment could be anything. I mean, which is there on the road, right? I mean, of course, I'm not going to be able to figure out what to do in water or in the sky because that's not the environment I've been trained on. But if I'm on the road and if I'm a car, then I know exactly what I'm processing and all of that. So that's the environment, right? So it has all the elements, the dynamics, the rules, and the agent will interact from it and then receive the feedback, and then it will change, the actions based on those feedback. So environment in the case of the self-driving car is traffic conditions, road network, what vehicles are there on the road, how's the signal environment there, right? And the whole physical world the car operates in. Moving on. State. This is important because a lot of people get the idea of all the other things, but the state is a little bit harder concept to get, right? So I'll give you maybe a few seconds to take a look at it and then I will explain. Okay, so one of the things that you should sort of like get out from the state is that state is dynamic, dynamic, right? Within that environment, at a given point of time, where you are is basically that state, right? And that state is an input parameter to the car or to the agent to say, okay, given that you are in this environment and given that you are in this particular state, what are the the policies that you should be looking at in terms of maximizing the reward, right? So that's what basically the state is, right? So let's say I'm again going back to the car example. What is the speed of the car that if I'm the self-driving car, what is my speed as of now? What is the speed of the nearby vehicles? What obstacles are there? Are there pedestrians on the road? All of those things at that moment only, when I have to make that decision, whether to slow down, whether to accelerate, and all of that, because I need to process all this information, and that's what the state really sort of like relays to the car. That okay, you don't have a lot of traffic in front of you, and you will get reward for reaching the destination on time. So the car will say, okay, given that I don't have a lot of traffic in front of me, I can accelerate, right? Or just the opposite of that. So the car says, okay, if I reach on time, I will get a reward of this. But if I get into an accident, I will get a penalty of, much higher. So if I see, which one I'm gonna gain more, given that I'm in a tough traffic situation, the car will say, okay, I'm gonna let go of reaching there on time, but I will try to avoid the collisions, and that's again the state, right? So that's what basically the state really boils down to. Actions. Again, take few seconds. Okay, so given the state, given the environment, what should I do now? Whether I should accelerate or brake or turn left, turn right, change the lanes, slow down, right? Or whatever, I mean, could be the different actions. Even, switch on the wipers, for example. That is another one that the car will have to take the action on. Switch on the lights if the lights are not always on, right? All of those things are, depending on the state the car is going to take the action on. Reward. Very simply, I'm going to accelerate a little bit because we have another 15 minutes. I want to leave the Q&A time and do the Python demo as well for you. So I'm just going to accelerate a little bit. And of course, we'll go till about 10:15 or so because we started late. 10:20 also we can do. So we don't have to necessarily rush for it. Um, right. So reward, we have spoken at length in terms of, the reward mechanism. So for car, what will the reward look like? So you'll get a positive reward if you reach the destination on time. You'll get a negative reward or negative reward. You'll get a punishment if you get into a collision or you get into a traffic violation. So let's say the speed limit was 70 and the car was doing 80. So the car will get a ticket, right? So all of those things are nothing but your mechanism to really see, whether that was the right behavior or not, to demonstrate at that point of time. And that basically the overall objective is that how do I promote safe driving behavior in the car is what the reward mechanism will be, right? Similarly, for the dog, the reward mechanism could be a cookie, could be a, whatever treat that you give to the dog to go fetch the newspaper or listen to you, sit down, stand up, whatever, right? I mean, that's what basically the reward is. Policy, yeah, this is interesting because we'll be looking at that in the Python example as well. So take a few seconds. Okay, so the policy is a set of rules that agent can follow uh, depending on what state they are in, and that will basically decide what actions they take next, right? So policy is nothing but it's a mapping from state to actions. Again, look into this big environment, and if I'm there in that environment as an agent, and then within that environment I'm in a particular state. Given that state, the policy says that if you are in this state, what should you do in terms of the possible actions and which actions will give you the highest reward. So it's not necessary that only one action will be suggested at a one state. There are multiple actions that the policy will have, but policy will also have the rewards associated for each of those actions, and that is how basically the agent will make the right decision, right? So the policy in the in the case of the self-driving car could say that you should accelerate when the road is clear. That's one policy. You should brake when the pedestrian is detected. That's another policy at a given state, right? And you should turn at a particular intersection. That's the third policy, right? So depending on what we're looking at, some examples of the policy, right? Value function, which is related to the reward. Okay. So I think by now we are already aware of the state and action. So actions are tied to a state, and that is what basically the policy is suggesting. And policy is being led by the value function. Whichever policy is going to give you the highest value, those are the actions that we're going to take. So that's what basically it is. And you can read on the self-driving car. I think it's quite obvious in terms of what we are looking at. This is important because the algorithm that we'll be doing in Python will be what we call as a queue learning, right? And there's a queue table as well that we'll be looking at, which is sort of like, quality table or overall learning algorithm name that we're looking at. So we're looking at what exactly that is. So I'll give you maybe a few seconds again to take a look at that. Okay, so you will see when we do a Python example, there is a queue table that we create. Queue table will have all the different states on the in the column. So this is basically nothing but your states, and these are nothing but your actions. And for each one of these state actions combination, it will have a value, which is your reward or the punishment, basically the point system. So you can think about, what points I will get if I at this state take this action, right? So that is nothing but the Q value of the Q table. So I hope that makes it clear for you. And I will show you how that table looks like in our example here. Okay. So one state to another state is nothing but your state transition, and how exactly that changes the overall reward and what we're going to do is nothing but the state transition function. And we'll discuss that more in the later on. This is very interesting concept, and you'll see that I have parameter in the code which will talk about that learning rate. So I'll give you some time to take a look at it. And if anybody can tell me, what do you think this is similar to in terms of the conventional ML? Have you seen anything of this nature in the conventional ML? Any parameter that you think comes close to it? I'll look at your chat just to really bring you back in the conversation. Learning rate. Okay, so I'll talk about this. So learning rate, folks, talks about the parameter alpha, first of all, and it basically strikes a balance between preserving the existing knowledge and incorporating the new knowledge, right? And I was looking at your point. I mean, I think this just comes in at the, like, I mean, maybe you have made that comment earlier on, but I think you can think about this parameter as, if you're aware of the exponential smoothing in the time series model, right? So exponential smoothing has those alpha, beta, and gamma parameters, right? Triple exponential smoothing, for example, how much I'll give importance to the latest data point versus the previous data point, right? Similarly, learning rate also says how much I should leverage in terms of my existing knowledge and how much I should actually pay attention to the new data points is what the learning rate is, right? And that will basically say how quickly I update my Q values and all of that. Yeah, similar to the deep learning as well, right? So in terms of if you learn too fast, you may not get to the optimal, right? In terms of the stochastic gradient descent and all of those things, learning rate, you need to optimize the learning rate, right? So that's one parameter that we definitely look at in terms of optimization within the reinforcement learning as well, right? I'll move on. Discount factor. Again, you will see this is similar to some of the concepts you may have seen in the conventional ML. So I'll give you maybe a few seconds to take a look at it. Okay, so discount factor is in terms of striking a balance between the instant rewards or instant gratification and long-term rewards. So how much importance you want to give to the events or the rewards which you get immediately following that action versus the rewards that you're going to get if you demonstrate the right, if you use the right policy for a longer period of time, you'll get a bigger reward down the road. So what should be the balance between something which I get in the future versus what I get now is what the discount factor is all about, right? This is a good example. Car may get higher points if it speeds during the, on the intersections, right? So, which will basically mean that it will get lower rewards because it's reaching slightly lower on time because it's just slowing down the intersection as a precautionary measure. But longer reward because of the slowing down on the intersection may result in lower accidents for the car down the road, right? And that may have future benefits. So safe driving, for example, if somebody is doing a safe driving, they get higher rewards down the road. So same thing, the self-driving car has to really balance out. I mean, do I really look at the instant gratification, which is if I reach the destination on time just for this event, or do I want to really build that behavior that over a period of time I will not run into the accident, right? So that's the discount factor that we're looking at. Exploration rate, we have spoken about this in the earlier example, which is the epsilon value, which is says how much something that we already know we should leverage versus something that we want to explore. And if you don't explore, like I said, I mean, your rewards will be generally lower. So that policy is what we call as the epsilon greedy policy. And that basically feeds off this number epsilon, which will say you can take exploration path for this probability epsilon. And 1 minus epsilon will be your exploitation. So you should only follow what you know as of now, right? So for example, the car may say, okay, let me see if I can figure out a shortcut, right? I think somewhere over here it might be mentioned. A wider range of action leading to more diverse driving behaviors, and maybe it's not mentioned, but maybe the car can say, okay, you know what, I think, I mean, there's a shortcut that I can take from over here, and that will actually take me to the destination faster. So that's an exploration. We don't know because we don't have any track record in terms of the learning behavior. But if the car takes the usual path, the usual speed, all of those, that's the exploitation. And that policy, again, very, very important term, is what we call as the epsilon greedy policy, right? So we want to be greedy, but not to the extent that we are actually losing all the points that we're going to have. Another very important term, which you'll be seeing in the Python demo as well, episode. So I'll give you a few seconds. Okay. So the episode is nothing like, nothing but like an epoch in the deep learning for the people who are aware of that sort of terminology, right? So one entire learning cycle is one episode or one episode, right? And you're going to have multiple episodes in training your RL engine, but one entire cycle where I begin and that session ends because of either getting to the point where I wanted to, or making certain mistakes and getting killed in the process, right? So that's one episode. So in terms of the games, you can see my episode could be, when I started playing the game and when the game ended. Because I mean, I may have reached that level and say, done. There's nothing you can do now. Or you may have gotten shot at and you actually no more in that game. That's the episode that you're looking at, right? In the self-driving car example, from the start position to the destination position, or if the car breaks down or runs into the accident or does not reach that destination on time, is one episode, right? And that includes basically all the maneuvers it has done, all the interactions, all the encounters, and everything is all captured there, right? Explore, exploit dilemma. I think we have spoken about this earlier on. So, which is nothing but how much we should be exploring and how much we should be exploiting, and that is basically feeding into the explore exploit policy with the probability epsilon. And I think this is where I was looking at that in terms of taking the shortcuts and figuring out whether I can go faster, go slower, all of those things, go to the unfamiliar routes. That's where basically the car will be trying to optimize the action. Epsilon greedy policy also we have spoken about. So now I will shift gears, and I think we've covered, I'll say, probably a lot of those major concepts. But is this the comprehensive list of all the things, all the terms which are there in the reinforcement learning? Probably not, right? So there's much more to it, and you can explore that later on. Just like what we're talking about, the explore exploit. But I think these are things that you should definitely exploit in terms of learning that behavior, right? Some of the main algorithms which are there, and we won't have the time to talk about them in details, but maybe in the future webinars we'll do some more hands-on sessions on them. We will definitely look into the Q learning. What is a Q learning? It's a model free, so there's no deep learning algorithm, there's no machine learning algorithm, there's nothing, right? So it's more about equations, more about if you do this right, then you will be getting this reward and all of that, and basically having a reward mechanism for the state and action pair, which is what we're going to look into. Deep Q network basically enhances the Q learning with respect to the deep neural network. Policy gradient method in terms of optimizing the policy parameters via some sort of optimization algorithm like the gradient descent and ascents and all of that. Monte Carlo simulations, I mean, it will simulate. So this is a simulation-based, right, mechanism in terms of figuring out, what should be the right actions that we should be looking at to maximize the reward. Over here, you have the basically actor and critic, which is the actor is the policy and critic is the value function, and they will always challenge each other in terms of making sure what we're looking at. Other algorithms, and then we have the Markov process. Markov process is very, very important, and most of the RL will actually leverage this, which basically works on the concepts of the uncertainty, and all the different probabilities and the events tied together with a certain probability. What should be the next action that we should be looking at? Very, very important concept besides the RL as well. The whole Markov engine process, right, which sort of looks into the sequential decision making. So I'll move on and talk about the demo of the Python reinforcement learning. And then I will open up for the Q&A, right? So the demo is, and I will share all the codes and the presentation with the team, and you can definitely reach out to them to get this information from them. So just allow me a moment. Okay, so before I go to that one, I will just talk about what this RL demo is all about. So just maybe quick 30 seconds and so on and so forth. So this is what the taxi demo is that we're going to do the live coding on. And this is coming in from OpenAI Gym documentation or Gym library. It's called Gymnasium now, but Gym is also something that works, right? And I'm going to use the Gym. Gymnasium is a more recent version of that, right? And what it is having is, it is having 6 actions the car can take. What are those 6 actions? They are listed out over here. Move south, move north, move east, move west, pick up passenger, drop off passenger, right? So these are the 6 actions the car can take. And there are 500 discrete action space basically that they can, what do we call that, states which are possible within this environment, right? Why 500? I'll just give you some math on that here as well. So there are 25 taxi positions. Taxi could be in any of, it's a basically 5x5 grid, that environment that OpenAI has, 5x5 grid. So that's 25 taxi positions. The taxi could be, or the car could be in any of these positions, right? There are 5 possible locations of the passengers at any given point of time. So why 5? Because these are the locations where the passenger can be met, blue, red, green, yellow, and all of that. including the car. So 5 possible passenger positions and 4 destination locations. What are the 4 destination locations? Again, these red, blue, yellow, and green are your 4 destination locations. So there are 500 different states that you can be on in any point of time, and 6 actions which can be taken at any point of time, right? So what does it really mean? Going back to my writing pad over here. Oops, did I close it? I think I have closed that presentation. Just a second. Right. So in terms of the queue table over here, and you know that we spoke about the queue table. So the queue table looks like this. Sorry for the bad drawing over here. So on this, you have actions, and we had 500 actions there. Sorry, my bad. 500 states there, and 6 actions that we have spoken about, right? So this queue table is going to be nothing but an array of 500 by 6, right? Why 500 by 6? Because 500 states are possible in that environment, and 6 actions are possible in that environment. So I will just show you. I'll jump a little bit here and there to show you that how that is coming along. And I believe it's right over here, right? So don't worry about where exactly and how did you get the 506. I will walk you through later on. But if I print my queue table shape, my queue table shape is okay. Maybe in the next code I have printed it or no? Okay, no, it's here on in this output. So I just need to scroll down. Okay, maybe I can just leverage the mouse to do it faster. Hold on. So over here, you can see that I have the queue table shape as 500 by 6, right? So I hope everybody is able to relate to that. So why 500 by 6? Because these are the different positions where the car can be. These are the possible location of the passengers and so on and so forth, and the actions it can take, right? So I'm just trying to see what else to mention over here. This is important as well. So what is the reward mechanism in place? Reward mechanism is -1 per step unless other reward is triggered. So how many steps you're taking, how many times the car is moving, -1, unless there is a reward for taking that step. So we don't want just you to take a random step here and there, right? So we're trying to penalize for the random steps. 20 for delivering the passenger. So the aim is that you have to pick up the passenger and then deliver the passenger on the right location. That's the 20 marks, right? -10 for executing pickup and drop actions illegally, meaning, I mean, you think I'm picking up the passengers, there's no passenger there. Or if you say that I'm dropping off the passenger, but the passenger does not want to be dropped over there. So that's what basically the penalty or the reward mechanism is in place. And there's a visualization as well that you can try out. So I'll share this link that you can actually take a look at later on whenever you have time to see, what is it that we're trying to mimic, right? But I'll just run you through the code at a high level and then open up for the Q&A, because I think that's going to be more important for you to get more familiar with that as well, right? Okay, there we go. So I have 2 sections of the code and I will try to zoom in a little bit so that you can see it better. Probably too much zoomed in, so yeah, that's fine. So we've spoken about this 10-point penalty for illegal pickup drop, 20 points for successful drop off, 1 point for every time it takes any steps, right? So import gym is the library that we will be using for creating this RL example. There are many other libraries out there, but we're just using this OpenAI library called gym, and there's a better version called gymnasium. Then we are importing some of the usual suspects in terms of the random number generator or the function basically from which will generate a random number, NumPy, and pandas also if you want to create a data frame. This is where we are loading that environment, creating this text environment, which is very specific to the RL. You wouldn't see that happening in the linear regression, logistic, or decision tree, anything of that nature. So this is where we're creating that environment. We are resetting this environment. and we are saying number of episodes is 100. What do you mean the number of episodes is 100? If you got the like some of the discussions in the deck, what do you think is the number of episodes? Any idea or any guesses? You can write on the chat window if you want to. So it's basically yeah. So how many time it's yeah, training epochs, right? So how many time I'm letting the car go from start, like learning something and then either dropping off or getting the penalty because it dropped off the passenger in the wrong location. So how many times this entire process is going to repeat? So you can imagine that there's going to be a for loop which is going to iterate through it, that many times you're going to learn that behavior. Number of steps is how many steps the car can take, because there are 500 different steps possible. But I'm saying you don't have the like entire freedom of taking the 500 steps. I'm not giving you those things. I'm only giving you 100 steps to do within each of these episodes, right? So that's the number of steps that you're looking at. This is nothing but your Q table initialized in terms of the overall value that we're going to have, right? So right now I'm just putting the zero values, and as we start learning process, this will be populated with the actual values, and I will demonstrate the Q table how it looks like in the next code. I'm not going to run this code because there is some indentation problem because of the commenting that I've done. But I wanted to explain line by line so that when I run it, then you can visualize what is happening. Remember these things, we just spoke about that. Alpha, gamma, and epsilon. Alpha, anyone who would like to remind what is alpha? It says learning rate, but what are we trying to balance by looking at the alpha? Just a few line or one liner is good enough if you know. Alpha is how much you want to retain what we have already learned versus how much importance you want to give to the new information that is coming in, right? So how much to learn from how much to retain from whatever you have already learned versus how much importance you want to give to the new parameter, right? In terms of just sort of like balancing out the things, right? Gamma. Again, what do you think this is talking about? Exactly right. So how much we want to give importance to the latest information versus the information coming from the future is the gamma. So instant gratification versus the long-term reward is what we're trying to balance out. And last one, epsilon. The explore exploit dilemma, right? So how much you want to go with the something that you've already learned versus something that you want to explore and see what is the reward that you're going to get. So if I have epsilon value as higher, that means I'm going to do more exploration, right? But in this case, I'm saying 90% of the cases you will follow the explore, and only 10% of the cases you will follow the exploit policy, right? This is where the Q learning algorithm is getting initialized, right? So for episodes in range num episodes, which is nothing but your number of iterations that you've gone through. Sorry, the num episodes is over here. I'm resetting the environment, resetting the reward. For step in this range, I'm picking a random number from a uniform number generator. So what this function does is basically it's going to pick a number from 0 to 1. And 0 to 1 is nothing but a probability. And that probability will be compared to the epsilon. And if that probability is less than epsilon, you will go on the path of exploration. And if that probability is more than the epsilon, because we said, no, you cannot take that action beyond the epsilon probability, then you'll be going in the exploitation. And then you'll be looking at the Q table. And the Q table has the basically for that state, what action gives you the highest reward. So argmax is telling you for that state that you're in, what action is going to give you the highest reward. So that is the action that you should choose. And that is nothing but the exploitation mechanism, right? And then for the action that it has taken, we will get the state. What should be the next state? What is the reward? Are we done? Meaning, have you already accomplished your goal, or you have run into the problem and all of that? And we'll update that table. This next equation is very important, which is what we call as a Bellman equation. This is what we use to update the Q values based on a certain action the agent has taken in a certain state. And based on that, this is where you can see the alpha, beta, gamma is also coming in. You will be seeing, what is the next. So given that we are in this state, what is the value that we are assigning, the Q value, which is basically maximizing the reward for the next set of action for the current state given that we are in. And that is what basically the car will follow in terms of taking the action forward. So this is what the Bellman equation is all about. And then we are updating the reward in terms of whatever reward the car has gotten so far. And we are looking at this, and then we are printing, how many episodes have printed out and all the other diagnostics with that, right? So what I'm going to do now is I will connect my system and run the code so that you can see how basically it happens, right? I think it's already connected. So this is the code I'm going to run. And it will generate a certain output as well. So, and I will be happy to share this code with you. So it has already run, right? So I have already walked you through, but I don't have the comments over here. So that's why I wanted to walk you through over there. So you can see this is how, oh, by the way, I mean, I think I have changed certain parameters in this. So you should not get confused. So in this case, I am saying you can have 1,000 episodes. So 1,000 times it's gonna learn that entire behavior or go through that entire loop. And in each of these 1,000 times or episodes, it is going to take 200 steps for learning the optimal behavior and maximizing the rewards. And I believe I may have changed certain alpha, beta, gamma over here as well, also alpha, gamma, and epsilon over here as well. And point system continues to be what it is. And all the other code continues to be what it is, right? So let's see what exactly happens in terms of the actual learning. And there are codes out there. If you Google, people like people have done, other coders have done a better job in terms of visualizing some of these things as well. So this is not like the best possible output, but you can definitely visualize that. So unfortunately, because of the time limitation, I couldn't get the visualization library to work over here. But you can see, at any point of time, it can draw the car where exactly it is and all of that. But I think that's okay. We're all, related to the numbers, so we like this better. So okay, so you can see episode 1, it began with a whopping penalty of 596 negative, completely wrong behavior. 533, 298, again the wrong behavior, right? And so on and so forth. So it's learning, and we are looking at what is the reward it has gotten in the process over time, right? So let's fast forward. Let's fast forward to something else. So still learning. Each of the episode, it's getting a certain reward, whether it's a positive reward or negative reward, right? So we'll continue to go down. And you can see now we are in the 600 episodes, and the numbers are not looking that aggressive, either positive, I think mostly negative earlier on. Now you can see there are more positives as you're going through. It has learned that behavior, the Q table is getting updated and everything, right? And if I continue to scroll down, finally, after the end of this evaluation, it has a positive reward of 27 points, right? So you can see if I trained this vehicle for 1,000 episodes, it has learned that behavior over a period of time because of that Q value, the policy, the state, all of the things that you've spoken about. It has learned that behavior. And remember, there's no algorithm. I mean, I wouldn't say there's no algorithm. There's an algorithm, which is the Bellman equation that we're looking at in terms of the policy and all of that. But there's no ML algorithm. There's no deep learning algorithm. None of those things are there. So that will come in a more sophisticated version of that. And the Q table looks like this, which is what I printed out over here. So if you want to see how my Q table looks like, so I'll just print that very quickly. I believe we are calling it Q table only, or what is the name? Yeah, Q table, Q underscore table. So I can say, please show me the Q underscore table. And it will be very hard for us to visualize over here because it's a NumPy array, 2-dimensional array. The first dimension is all the states, and the second dimension is all the actions, right? So you can see these are the Q values basically for each of them. And it's very hard to visualize all of them over here, but that's the shape that we're looking at in the previous code, 500 by 6 rows, right? Now you can try to change some of these parameters once you get this code. So instead of saying, I want to go 5,000 cycles, oops, not 51,000, 5,000 cycles, and you can go with 300 steps, right? and you can do more exploitation. I don't know whether we're going to get a better result or not, but I'm saying, you can explore more. And just for the heck of it, I'm going to change the alpha in terms of the learning rate as well. So I'm saying you can learn more, and the discounting I'm going to lower. So I'm saying, future, not that much, but maybe 0.5, just to see what really comes out from this event now, or this experiment now. So it's running. It's going to take slightly longer time, of course. And I will scroll down to show you how it's actually coming to that state. So you can see it's already in the 2000s, 3000s now. Earlier experiment was only 1000 episodes. Now we are getting to this. So you can see the reward has gone higher. Probably it could have gone higher, better than what we had earlier. I think it was in 20s. Now it has gone higher to 30s. So that sort of wraps up the demo, folks. So I will take a pause and, happy to take up your question and comments. I know we are slightly over time as well, 10:20 now, IST, but let me just go back to the original list of questions. So I will try to answer that one by one. If I miss out something, feel free to retype your questions. Reward and punishment, Anamika, I believe now you're clear, right? So with respect to all the things that we've gone through, so there's a point system that we actually have for taking that action. How we punish robots versus the reward, Ayaz, I think, that is also related to that. Veda says agent's role will always be robot in all the cases of reinforcement learning. Right, yeah, agent is basically getting rewarded from that mechanism only, right? There's no emotion, so they will just follow that in terms of maximizing the reward. When we respond to any of the responses from ChatGPT, that's correct, Vatsala. I think, excuse me. CNN will be characterized as a supervised learning. Correct. Yeah. Convolution neural network is for the image and some of the text also people have used, but mostly for images. So that is a supervised. Chat GPT is mostly unsupervised and reinforcement learning. Very little supervised learning. In fact, for the large language model, we don't really look into the supervised learning at all because it's not even possible, right? If they are scraping the entire web, getting all sort of information from all the books, all the chats, all the blogs, all the web links, right? How would you train that? So they're mostly unsupervised learning algorithm and reinforcement learning algorithms. They learn on their own. They label on their own. They learn on their own. They reward in terms of what they're doing. All of those things are like mostly unsupervised. No, I think we have already addressed that. So they're not trained on the data. They have used that data, Farhan. That would be the correct term. I don't have the labeled data on the Reddit, for example. So nobody has sit down and say, okay, these are the 2 million pages on Wiki, and this is what this page is all about. This is what you should say. So none of that training has been done. Can we apply time series forecasting with reinforcement learning? Any examples and results accuracy as compared to supervised learning? I haven't tried personally, but I think definitely you can do in terms of building an agent for doing the prediction of the time series forecasting or forecasting model. And if that forecasts well, then you are actually doing that reward mechanism. But I have mostly used, the usual suspects like LSTM or the exponential smoothing or ARIMA, or some of those things, right? Okay.
Folks, you may also raise your hand and I'd, unmute you and you could
Yeah,
directly
yeah,
speak to
definitely.
Ratnakar.
Can I put the code also? Should I in this one code in the presentation, or you want to share that later on with the folks?
Yeah. What do you think would be the best way? How
Okay.
many lines of code do we have here?
It's very small. So it's not really that big. So let me just try to download and then share that with the people. Let's see if I can share
Yeah,
it
if
with.
you can attach the file, then well and good. If not, then post the webinar along with the recording. I can send it over.
Right, right. Um I'm just looking for the attachment window over here. No, I don't think I have that functionality actually, Shraddha.
No worries.
Yeah, so it says Dropbox, some of those things, and I don't have that, or maybe I'm just not exploring in the right area. Let's see, chat, I'm already there, attachment. No, it doesn't give me that functionality. Anyways, I'll share these files
Right.
and you can share with the participants and the people who registered, right?
Sure.
Okay. Great. Anyone who would like to unmute and ask me question directly? I hope this was a quick introduction which you found useful. I mean, again, in a 1 hour or 1 hour 30 minutes webinar, we should not pretend that we got all the things, but at least you should get a broader view of what is RL, what is reinforcement learning, how does it really work, what are the different terms, right? And somebody asks you in a discussion or interview, I mean, you should not be completely blank. I think that itself will be a big win. And you should then figure out whatever work you're doing, how can you start to leverage some of the reinforcement learning in your work. And believe it or not, I think the most of the work in the coming days, weeks, and months will be happening in the reinforcement learning, in my view, right? Because that's where, I mean, the world is going. You have tons of data. You have automated things, right? So how can you build those agents, those bots, those intelligent, entities which can take these actions on their own? What is the state of foundational AI in Indian startup? Vatsal is asking. I don't know, Vatsal, whether you go by Vatsal or some other name, but I apologize if I'm mispronouncing your name. What do you suggest a new data scientist, Vatsal only, new data scientist should shape his her career given things are moving so fast, alarms being raised about the state of AI? I think, Indian AI ecosystem is, I think, more and more poised towards product based growth, in my view, right? So far it has been more as a service mental model. He was, give me the model and I will build that model and give it to you, right? So that is going to change over a period of time. I think you'll see more and more product companies, AI product companies coming in, leveraging the large language models, leveraging some of the things which are evolving fast in terms of the compute and all of those things. So the future looks quite bright for anyone who is a data scientist or in early days or trying to start their journey as a data scientist. I'll say, don't get trapped into all the hype that, I mean, I should not learn Python now. I should go and directly type my code in the chat GPT and I will learn the Python that way, right? I mean, that is one way, but I think still fundamentals must be there, right? But not to the extent that we were looking at earlier, right? So, I mean, I don't expect you to memorize a formula. I don't expect you to tell me what is the math behind the mean square error or the root mean square error and all of that, right? So, I think those things are not required, but I think definitely other things are there. Yeah, so I think there's a follow-up question from Vatsal. So in a way, we are consumer of already built modeling algorithm. Absolutely. And I would encourage all of you to bring in this efficiency, right? So I mean, there's no harm in leveraging ChatGPT for your coding. This is not a school assignment. If you're able to solve a real world business problem by leveraging some of these tools, you should do it. You don't get another extra bonus points for saying, no, I did it everything on my own. This is not that sort of game that you're playing in this world. If you are able to solve the business problem faster, in a more efficient fashion, if somebody would have taken 10 days, now you can do it in 1 day. I don't care where you got the code from, how you did it, and all of those things. If it is working, great. You did it faster, even great, right? So that's the mental model that we actually should have as of now. How far reinforcement learning would be helpful for attack detection? Oh, that's a great question. I think, I mean, all these things, things which have not happened or will be very, very difficult for us to get the data point are in the realm of reinforcement learning, cybersecurity, fraud attack, phishing attacks, and all of those things are in the realm of the reinforcement learning, right? So I can create that agent, I can have that environment where it's gonna get hit with certain sort of event, and they have to really learn that behavior, how to avoid that, right? So all of those things are there, and that gets combined with the synthetic data as well. So you have to create those data points where, for example, let's say, I mean, I haven't, let's say I'm running my loan books and I keep on leveraging on the fintech example because I come in from that world, right? I mean, to a large extent. So let's say I haven't seen a bad rate meaning the portfolio NPA, non-performing assets of 20%. What can I do to really mimic that behavior? So if I have 20% bad rate in my portfolio, what will be happening? Who will be defaulting? What will be doing? What should be our action? I cannot wait for that event to be happening. If that event happens, then I'm dead already as a fintech company. If I'm having 20% loss rate, I'm already out of business long time back, right? So I have to generate this data. I have to generate this sort of environment where these things are happening, and then I have to figure out, if I start to get this signal that the bad rate is actually trending higher, what are the actions my policy should be doing, my lending policy should be doing in real time to tighten the grip on the like who I am lending to, how much I'm lending to, and all of those things, so that I don't run into that situation. So all of those are in the realm of the reinforcement learning and some of the simulation, like a Monte Carlo simulation that I mentioned in this slide. Does DevOps pipeline change for RL? Shraddha is asking. I think it depends, Shraddha, what sort of model you're fitting in. But I think most of the ML ops, or I mean, I'm using the ML ops because I'm more familiar with that term, will be something that you can plug and play a reinforcement learning model on. They're not very high in terms of the consumption of the compute and all of those things. Right? Or they're not going to ask for certain other things and stuff like that. But it all depends on the model that you're trying to fit and how complicated that simulation is, or that environment is that you're trying to build. I'm happy to spend more time, folks. I mean, as long as there's a question, I'm happy to be here. Feel free to ask me anything.
Yeah, participants, we urge you to maybe either raise your hand or, yeah.
Veda says, what will be the best deployment platform for the RL model? Okay. It really depends on what your org is using. So whether it's the AWS or GCP or Azure or H2O or any other platform, I don't think that should be a challenge. Or if you're running an experiment on your own local machine, like I said, I mean, these are not as computationally intensive as LLMs, for example, right? So if I want to train an LLM on my model and fine tune that model, it won't work on my hardware. But reinforcement learnings, I mean, even the complex algorithms will really work out because they are slightly lighter. I mean, the moment you get into a algorithm like DQN, for example, deep learning Q network, right? I mean, that is going to consume the bandwidth because now you're in the realm of the neural network and all of that. But if you want to do something hands-on and you want to deploy that, I mean, even your hardware can be, something that you can look at as a first bet that should work out. Other questions, thoughts? Thank you, Vatsal, and thank you all of you for attending. So happy to take up any questions later on as well. Like I said, I mean, you can ping me on LinkedIn. I'll be more than happy to help you. You can reach out to Shraddha for any follow-up questions and thoughts, and we'll take it from there. Sanjay says, I want to scrap data from web. How can I make sure it's legal? So that's a very different question, Sanjay, but I can tell you web scraping is always in a gray area, right? So you should read what their robots.txt file says for any of the website that you're trying to see. So there will be certain websites which will, no, there's no crawler allowed whatsoever, right? You cannot build any scraper. There will be websites that will say, no, don't break down my system, don't get any PII information, and as long as you do that, you're fine. So look into what they allow or don't allow, and talk to some of the professionals in this area. Even though web scraping is something that everybody frowns on, but I think web scraping is also very, very important tool in our kitty that we should be exploring. So, but I mean, I don't have a straight answer on it. So it depends on the site that you're trying to explore from. Okay. Any other questions, folks? And if you don't have any questions, you can drop off. Feel free to yeah. Shraddha has already put the email ID, so you can reach out to
Correct.
Shraddha for any further questions.
Correct. Ratnakar, just before that, we'd also like to get
Yeah,
some
yeah,
feedback.
yeah, absolutely.
Uh,
Yeah, yeah.
I've,
Let's do the feedback. Sorry, my bad. I
no, that's okay.
yeah.
No, no, that's okay.
Sorry.
I've,
Just take that a few seconds and fill out that feedback to be super helpful.
yes, please do. And meanwhile, also others take this as a golden opportunity to, get your questions answered
Yeah,
in the
yeah. Happy
industry's
to take
best.
up any questions as well.
Yeah.
While we are filling out the feedback, if you're done with the feedback, you can ask me any question, anything that comes to your mind. I will try to give you my 2 cents on it.
Yes, folks, go ahead and maybe raise your hand or type in your questions. Or you could also email to us. I've sent you my email ID.
Yeah.
We'll give it another 2-3 minutes, Ratnakar. Sorry to keep you
No
waiting.
problem. No problem. No no problem. I'm here. I mean,
Thank you.
I don't have anything planned for at least the next 1 hour. So I just thought. Can RL be used for a recommendation engine? Absolutely, Randolph. I mean, big area where I mean recommendation engines can use reinforcement learning, definitely. And I think, in fact, one of my maybe you were not there during that time, or maybe I did cover that in more details. But reinforcement learning definitely plays a big role in the recommendation engines. And you'll see new and new areas coming in as well. I mean, so whatever are some of the things that I've highlighted on my slide, I mean, that's not a comprehensive list. As things are, I mean, things are actually not evolving, exploding in AI as we speak, right? So as we're looking at this explosion of a sort happening in AI, I mean, you'll see many new things coming in that we're not even aware of. Crazy new applications of RL coming in, right? So, and we are just, looking at a very, very minuscule things, which are the possibilities as of now. Where will code be shared? Shraddha, I'll just send it to you.
Yes.
I'll send the code and the deck both to you so you can
Done.
share with the participants.
Done. So, folks, we'll share an email after the webinar that includes the recording and the code
Yeah.
and the presentation, so you can go through. And
Yeah.
on an email, you could. That I have a question from Soumya.
Oh, okay. Where do you work, Soumya? So till very recently, I was with Amazon till February. I was heading the customer experience team, basically a team of research scientists, business intelligence engineers, business analysts for the entire like journey for the customer experience and whatever could play a role. And then after that, I played a role in one of the startups as a chief data scientist. And now I am advising and consulting a venture capitalist in the large language models implementation. Any particular resource you would suggest for getting into RL have background up until deep learning? Okay, so I'll just put that link right over here. I think it's there in one of my blog on LinkedIn. I'll just try to dig it up. So there's a Amazon MLU where you can see some of these things in more animated format. And there's a deep learning, RL book as well, which is available free of cost that you can go through. So I'll just try to dig up those two things. Give me 2 seconds. I got that link. So this is what will have the book link as well as the Amazon link as well. So you can just go through it and you can find the information there. And the book is, I think, released under the Apache or MIT license. So it's free use as long as you're doing it for the non-commercial purposes.
If I could just last question from Sanjay, and then we'll wrap up.
Okay, so I missed that question. Where is the question here?
Can you suggest some open source where I can contribute for AI and ML?
Can you suggest some open source where I can contribute for AI and ML? So Sanjay, you mean you want to work hands-on, or like you want to highlight your portfolio of the projects? If you can expand more on that. I mean, if you just want to get the visibility while you're typing a question, I want to contribute to the code. Okay, you want to contribute to the code. So it depends on your interest. I mean, there are a lot of open platforms on the Git, for example, you can contribute. There are a lot of codes which are trying to solve particular problem, let's say recommendation engine or default modeling, where you can contribute. If you want to contribute in the large language models, I mean, that's the buzzword as of now. There are a lot of LLMs which are hosted on Hugging Face leaderboard, which are open source and people can contribute. You can maybe fine tune the model performance, right? And you can push that as, let's say, you're just looking at Falcon from Dubai or UAE, right? So you can say Falcon underscore Sanjay could be a new model that you develop, right? And then you can push it on the Hugging Face and you can actually contribute. So, I mean, from very small things to very big things as of now, I mean, there are a lot of forums which are out there where you can contribute.
Okay. Sanjay, I hope that answers your question. Okay.
I can share some links with you, Shraddha, later on, so you can
Sure.
socialize with people. I
Sure,
mean,
sure.
if you
That'll
want.
be helpful. It'll be
Yeah,
super helpful.
yeah.
All right. Thanks a lot, Ratnakar, for taking the time on a Sunday to enlighten our audience with reinforcement learning and also answering their questions very patiently. Um, we from Project would like to thank you. And thanks, folks, for joining the webinar today. And I will be sharing information post the webinar. And yeah, thanks everyone.
Okay, great. Thank you again, folks. And it was good. And, I know some of the people are attending 1 a.m. in Florida, so really appreciate it as well. Hopefully, I mean, you got the value from the time that you spent and look forward to helping you for any other future inquiries as well. Thank you again. Have a good one, folks, and talk to you soon. Bye.